question that comes up quite a bit, especially when you start talking about pulleys, is mechanical advantage. So this is going to be a quick video on the idea of mechanical advantage. Mechanical advantage is using some set of tools, some set of simple machines, usually, to amplify your input force and get more output force. We get this anytime that we move. A simple version is when we move an object up a ramp. If I have a block with a mass of 100 kilograms, it might be a difficult thing to just straight up lift that some height of maybe 2 meters. But to push this thing up a frictionless ramp, if I've got an angle of a ramp here, I could draw a free body diagram. Say here's my mg, here's my normal force. I'm going to end up breaking my mg into components as you've done before, with that being the angle of the ramp. We're going to say this one and this one will cancel, so my gravity component that points down the ramp is just an mg sine theta. If theta is relatively small, let's say theta is 30 degrees, that's a really steep ramp. The sine of 30 degrees is a half, which means my mg sine theta would now be 100 kilograms times 10 is 1,000 times a half is 500 newtons versus the 1,000 newtons that it takes to straight up lift this. Now the force that I need to overcome is 500 newtons instead of 1,000, which is a whole lot easier to overcome. The downside is I have to move this up a much bigger distance, so I'm applying a lot less force. I'm just doing it over more distance. That's the idea of mechanical advantage. I'm trading off the amount of force. I'm lessening the amount of force, but my trade-off is always some extra distance. In this case, I would say my output force is the equivalent of lifting 1,000 newtons. My input force, the force that I actually have to apply, is only 500 newtons. So my mechanical advantage would be 2. Now let's look at how we do this with pulleys. You are almost never tested on mechanical advantage. As a side note, that's not something that really ever comes up, but it's a good way to think about these things. It has a lot of application in engineering courses. But if you were taking this as an engineering course, you would be taking a calc-based version. What if I have a box like this and I want to lift it? If I can put a pulley here and then attach to the ceiling up here, that's going to be my ceiling. Attach one side of this to the ceiling, attach the other side to a separate pulley that hangs from the ceiling, and then I pull on that. When I pull, I'm applying a tension this way of, let's say, 500 newtons. Maybe I'm pulling with 500 newtons. That means that over here, because it's the same rope, I'm getting a downward tension of 500 newtons. At this point, I'm getting an upward tension of 500 newtons. At this point, I'm getting an upward tension of 500 newtons. And over here, downward tension of 500 newtons. Ropes pull, so it's always about just looking at the point of attachment, right? At this point, pulling is up. At this point, pulling is down. Now looking at this pulley isn't fixed to the ceiling or anything like that. When I pull on this rope, this pulley will move up with the box. I am pulling with 500 newtons, but I'm getting 2 upward 500 newton forces. So I'm going to get a mechanical advantage of, again, 1,000 newtons of output over my 500 newtons of input of 2. I can increase that amount of mechanical advantage by adding more moving pulleys, but this is how I can use something as simple as redirecting force to be able to make things a whole lot easier for me. If I want to move this box up by 1 meter, I'm going to end up having to pull this over by 2 meters. But that's okay. The actual amount of force that I need to be able to apply is smaller.